This video is on Chapter 12, Part 1 on mensuration of squares, rectangles, triangles, and circles. Now in the earlier video, we covered the formula for the area of a circle. So this is given by pi r squared. And it was also mentioned that if r is equal to 14, then the area is equals to pi times 14, and we square this, resulting in 196 pi. Now although it is mentioned that we can use the calculator value of pi or 3.142, it is always better and recommended to use the calculator value of pi, because if you were to key it in, you have 3.141592654 or even more digits if your calculator allows for it. So the calculator value of pi is more precise. So by default, we will not be using this. And in mathematics, we will not leave our final answer in terms of pi unless specifically requested for it. So from here, we will need to evaluate this with the calculator value of pi. So taking 196 times the value of pi in your calculator, we get 615.752. There are more digits, but we are going to round this off to 3 significant figures, because the value of 615.752 and more digits is not the exact value. So rounding this off to 3 significant values, by default we get 616 square units. They did not mention the unit over here, so we cannot assume that it is in square centimeters, therefore it will be in square units. Now next, circumference, 2 pi r or pi d. In this case again, if the radius is equal to 14 units, then the circumference is equals to 2 pi times 14. Substituting, we get 28 pi. Multiply 28 with your calculator value of pi, we get 87.964. So from here, we round this off to 3 significant figures of 88.0 units. Now we are ready to try some examples. The length of and breadth of a rectangle, 40 centimeters and 10 centimeters respectively. It is always useful for us to do a quick sketch. 40 centimeters for the length and 10 centimeters for the breadth. Then we have a square. It has side y centimeters. So since it is a square, all sides have the same y centimeters. Now these two shapes, they have the same area. So part A, to find the area of the rectangle is straightforward. Area. We use length times breadth, so 40 times 10, arriving at 400 square centimeters. In part B, to form an equation in y and solve for the value of y, we will have to make use of the relationship mentioned over here. The square has the same area as the rectangle. So we know that for the area of a square, it will be the square of its side, so y square. Okay, so y times y is y square, and we know that this is equal to 400. So in order, this is our equation for y square equals to 400 is the equation in y, and now we have to solve for the value of y. Since y square is 400, we will need to take square root of 400. Now when we take square root of 400, we will have either a positive value or a negative value. So evaluate this, we have 20 cm or negative 20 cm. This has to be rejected because length cannot be negative. So this over here is our answer. Y has a value of 20 without the cm. Okay, now for part C, find the perimeter of the square. Perimeter, since it is a square, it is going to be 4 times of y. We have evaluated y to be equal to 20. So this is 80 centimeters. Here we have to write down the units. So in exercise 2, part A, the length of a rectangle. again, do a sketch, is 3 times its width. So the width is x cm, the length has to be 3 times of x cm. So from here we can write down an expression for either the area or the perimeter. So for part A, length is equals to 3x cm. Now part B, given that the perimeter is 144 centimeters, form an equation in x, and hence find the area. So work out the first few steps for you. The perimeter is 144 centimeters. So the perimeter of this rectangle is given by 3x plus 3x plus another x. So we have a total of 3x, 3x, x, and x. 6, 7, 8, 8x cm. This is the perimeter. Okay. Now 8x is equal to 144 as shown in the question. So from here we are able to solve for x to be 18. Now that we have the breadth, you can multiply that by 3 to find the length. And once you have the length and breadth, you can find the area of the rectangle. So finish this off and find the area. Next, we are dealing with areas of triangles. So over here, triangles is the area of triangles is given by half times the base times the, let's include one word over here, perpendicular. Okay, it is the perpendicular height. So the challenge is always to determine what the perpendicular height of a triangle is. Now we have 3 different triangles over here, in figure 1, 2, and 3. For the first figure, let's choose AB as the base. Okay, if AB is the base, then the perpendicular height will be from C down to this point. Here we have a perpendicular height. The height is always perpendicular to the base. So in figure 1, the perpendicular height is 3 centimeters. Area, half times of 4, which is the base, times 3, which is the perpendicular height, resulting in 6 square centimeters. Let's take a look at figure number 2. Again, let's take AB as the base. If AB is the base, where is the perpendicular height? Reminder, the perpendicular height is perpendicular to the base. So since we have designated AB as the base, we go over to the point that is not used, which is C. We drop down a perpendicular line to AB. So in this case, we have to extend the line of AB. Okay, so this is our perpendicular height of 3 centimeters. The area is half times of the base AB of 4 centimeters times the perpendicular height 3 centimeters. Again, we get 6 square centimeters. And the final case for figure 3. If we take AB as the base again, the height will be starting from the point that is not used in the base, which is point C, drop down a perpendicular line to our line extended from AB. So we have the perpendicular height as 3 centimeters again. Area is half times of 4 times 3, and we get 6 square centimeters again. Is the area of each figure the same? Yes. Explain why. They have the same base and perpendicular height. With the same base and perpendicular height, even though the shapes may be different, they are going to have the same area. Now in figure 3, BC is given to be 5.83 centimeters. Okay, so let's remove all the other information. BC 5.83. Find the perpendicular distance from A to BC. Okay, let's find out where exactly this line is. So a perpendicular distance from A, so A is over here, to the line BC. We have infinite lines from A to BC. These are all possible lines from A to BC. All of these have different lengths. Which exactly is the line that they are requesting for? They stated that they want the perpendicular distance. So out of all these lines, we are only interested in the line that is perpendicular. And this line that is perpendicular from A to BC is also known as the shortest distance from A to BC. Okay, so let us call this H. Let's give it a name, H. Let the perpendicular distance be H, cm. Okay, what is the point of doing this? Now we know that the area of figure 3 is 6 square centimeters. We calculated that earlier on. And since we know that BC has a length of 5.83 centimeters, if we choose BC now to be our base, then the perpendicular height, H, will be what we need to find out. And we can work that out based on the known area of 6 square centimeters. In other words, area, which is half, times the base. This time we are choosing the base to be BC. Substitute in 5.83 times the height H. This has to be equals to 6. It is the same triangle. So we're going to work this out. H will be 12 divided by 5.83. And the value is 2.0583. Round this off to 3 significant figures. 2.06 centimeters. So here we have the perpendicular distance of 2.06 centimeters. Moving on to exercise 4. In the figure, AB is 5 centimeters. Now take a look. 5 is written over here. It is a little misleading because it may mislead you to think that the length of BD is 5. So what you have to do is to indicate some way that, hey, 5 centimeters is the length for AB. So BC, we've got 4 centimeters, okay, and AC, a length of 3 centimeters. Find the area of ABC, the large triangle, for part A. Now, we only have learned the area for a triangle to be half times base times height, and in this case, the height is always the perpendicular height. A triangle has 3 sides, whether it is BC or AC or AB. These are the 3 different sides. For each of this side, it has a corresponding perpendicular height. For example, if we choose BC as the base, then AC will be our perpendicular height, since it is given in a question that the angle BCA is 90 degrees. However, if we choose AC as our base, then BC will be our perpendicular height. The final side, if we were to choose AB as our base, then this dotted line over here, its length will be our perpendicular height. So those are the 3 different cases. Then we have to be smart and choose either one of these sides of the triangle as our base when you know the other perpendicular, when you know its corresponding perpendicular height. So it makes sense for part A for us to choose the base as BC. Area is equal to half times the base of BC, which is 4, times its perpendicular height, which is AC, given to be 3. So this gives us 6 square centimeters. Now note, if you were to choose AC as your base and BC as your height, you will still get the same answer. However, if you were to choose AB as your base, so AB, the base is 5, we will need DC, which is the height, the perpendicular height, to find the area of the triangle, which we don't have. So we cannot select AB as the base. So in part B, to find the height of CD, we are going to make use of what we have done in the previous question to find the unknown perpendicular height. Okay, so knowing that this time we are going to let AB to be the base. Area equals to half times AB, which is 5, times its perpendicular height, in this case DC, or as the question called it, CD. Half times 5 times the perpendicular height of CD, this has to be equal to 6. So we are able to solve for CD to be equal to 12 divided by 5. 2.4 cm. Now exercise 5. The area of the triangle is 28 square centimeters. So we know that this has to be half times base times the perpendicular height. Find the perpendicular distance from A to DC extended. Now DC extended, we're going to extend this line. They want the perpendicular distance. So this is the unknown. They have given you in the question that the length of CD is 7 centimeters, and what this perpendicular distance over here from A to DC extended, wouldn't it be the corresponding perpendicular height as long as we set CD to be the base? Okay, so let perpendicular distance be HCM. In other words, our area, half times of base, which is 7, times H, this is going to give us 28. Please solve for your value of H. The final question on triangles. In the figure, AB is 4 centimeters. Okay, so indicate for yourself BC 6 centimeters. From B all the way to C, not to D. And the perpendicular distance from C to BA extended. So we need to be familiar with this phrase. BA extended. From B, go to A, and we extend it. So the perpendicular distance from C to BA extended refers to this distance. Is 3 centimeters. Now we need to find the length of AD. Do you see that it is the same type of question where we have one single triangle? We have one single triangle with obviously 3 sides, but if we were to select AB as the base, we have the corresponding perpendicular height, which means we can find the area of the triangle. Then we're going to make use of the area of the triangle to find this shortest distance from A to BC, otherwise known as the perpendicular distance from A to BC. Shortest distance, perpendicular distance, they are the same. This can be done by setting BC as the base of the triangle, then AD will be the perpendicular height. We equate that with the area that was found earlier on to be able to find the length of AD. So please try this question by yourself. The answer over here for you to check, AD will be 2 cm. Now we've got a few more questions on circles. So we're going to be using the formula for the area of the circle and perimeter for circles. In exercise 7a, the circumference of a circle is given to be 12 centimeters. Find the radius of the circle. So let's begin. Let the radius be r centimeters. So we're going to use this particular formula. Circumference equals to 2 pi r, and this is equal to 12 centimeters. We are trying to find the unknown value of r, so we are going to divide by 2 pi on both sides, 12 over 2 pi. So please use your calculator for this to find the value of r. So we arrive at 1.90985. Round this off to 3 significant figures, 1.91 centimeters. We are rounding off because the value given in the calculator is not exact. There are many more digits after the decimal point. Now moving on to part B, to find the area of a circle, this time they say leave your answer in terms of pi. So please do not use your calculator to evaluate the answer. Area is equals to pi r squared. We have found the value of r, 1.91. But then this is no longer in terms of pi. So we should use a value of pi of r that includes pi. So that is shown over here. R equals to 12 over 2 pi. So let us continue. Pi times r. R is 12 over 2 pi. And we have to square this. Okay, so please take your pencil. We are going to simplify this. 12, we divide by 2, it becomes 6. And 2 divided by 2 gives us 1, which we don't need to write it down actually. So let's continue. Inside the bracket, we've got 6 over pi. And we square that. So this means it is 6 over pi multiplied by 6 over pi. It is squared. So you multiply it by itself. And we see that the pi over here can be divided by each other, resulting in numerator times numerator. 6 times 6 is 36 divided by pi square centimeters. Okay, exercise 8, please try it by yourself. I'll give you the starting first step. Let the radius be r. So they gave you the area of a circle. You can work backwards to find the value of the radius. Then from the value of radius, you can calculate the circumference. Final question, number 9. Here we have O as the center of a circle, which has a diameter of 5 meters. So AC is 5 meters, meaning radius is 2.5 meters. We also know that AB is 4 meters and BC is 3 meters. Find in terms of pi. So in terms of pi means we do not evaluate it to find the length of B to D. So this is a similar question as our earlier triangle questions, where we are able to find the area of this triangle given that 3 is the base and 4 is the perpendicular height. So from then on, we set 5, which is the length of AC, to be the base, and B to D will be our perpendicular height. In this case, we will not have to use pi, since we are not dealing with circles yet. Okay, so please take some time to try this question. The length of BD is 2.4 meters. So please check this as your final answer after you have done your working. So finally, to find the area of the shaded region. Now the area of the shaded region, we can see that it is made of 2 parts. We can also tell that it is part of a semicircle. Okay, as long as we can find this area of the semicircle, which is half a circle, we take away the area of the triangle. We will be able to find the shaded region. So the working will be as such. Area of semicircle equals to half times the area of a circle, which is pi r, radius 2.5 square, half times of pi r square. So we're going to input this portion into the calculator. We don't want to touch the pi because they want our answers in terms of pi. So 2.5 square divided by 2 results in 25 over 8. 25 over 8 pi. This is the area of the semicircle in square meters. So from here on, area of shaded region is simply area of the semicircle, take away the area of the triangle, which you should have calculated in part A, to be 6. And now, this over here is our final answer. You can choose to combine this into one single fraction by making 8 as the common denominator. Okay, so this is acceptable, and so is this. 25 pi minus 48 over 8 square meters. And finally, to find the perimeter of the shaded region. Perimeter of the shaded region is given by half of the circumference of the circle added to 4 and 3. So perimeter is 4 plus 3 plus half of the circumference. Circumference of a circle is given by 2 pi times r. The radius was found to be 2.5 meters. So we result in 7 plus 5 over 2 pi meters. So we can leave it like this, or we can leave our final answer as one combined fraction over 2, 14 plus 5 pi. So this set of notes will be due on today's lesson. Please make sure you have all your corrections done for those few questions that I've asked you to try on your own. It is due today at 10 p.m.